Hey everyone, Mr. Russell here to take you through how to calculate the slope of a line. Okay, so on the screen right now, we have the definition of what slope is. So slope essentially is just the rate of change of a line. So if you watched the previous video on rate of change, we talked about what that means, right? A rate of change calculates the change in a dependent variable divided by the change in our independent variable. Okay, so in this situation here, let's look at how I do that. So let's not call it slope for a second. Let's call it rate of change. So I want to see from point to point, what is the change in our dependent variable, right? Which is always located on the vertical axis, which is the distance, over the change in our independent variable, which is on the horizontal axis, which is time. Okay, so if I want to calculate the rate of change, I would say to go from point to point here. It's kind of already labeled on this screen, but we're going up 260 units. Okay, so my change in my dependent variable would be 260. Oop, I want that to be in red. So 260 feet divided by the change in our independent variable, okay, again, which is time. So to go from point to point, we're increasing by 1 unit on the x-axis. So that'd be 1 minute. So we would say the rate of change here is 260 feet per minute. Also, the slope would be 260 over 1. So that's essentially what slope is, everyone. Slope is rate of change of a line. So if we used to call, or we do call, rate of change in dependent variable divided by the change in our independent variable, we might not always have a dependent variable and an independent variable. But if you look at where those variables are located, we know the dependent variable is always located on the y-axis and time is on the x-axis. So instead of saying change in dependent variable over change in independent variable, we say slope is the change in y over the change in x. And that's the big thing to remember. Slope is change in y over change in x. So let's say we looked at two different examples here. Okay, and I want to calculate what the slopes of these lines are. So that means from point to point on this line, what is the change in y over the change in x? So I just want to see, how do I travel along this line? Well, to get from this point, here to this point here, let's count. All right, the change in my y. I'm going up 1, 2 units. So I'm going up 2. And then my change in x, I'm going over 1, 2, 3, 4, 5. So I'm increasing by 5. So that means my slope would be up 2 and over 5. So the slope of this line would be 2/5. Okay? The next one, same idea. I want to see, how are we traveling along this line? So you get from point to point, what is my change in y over change in x? Well, first let's calculate the change in our y values. I want to always go left to right like we're reading a book. So we go, in this case, down 2 units. So my y values are decreasing by 2. And my x values are going over, let's see, 1, 2, 3, 4, 5, 6. So I'm increasing by 6. So then my slope would be -2, because my y values decreased by 2. My x values increased by 6, so it's -2 over 6. And the last thing we want to do is always simplify what our slope is. So -2 over 6 would simplify to -1/3. Now, the thing to remember, sometimes I get questions about, where does that negative sign go? Remember your properties of dividing numbers. If we have a negative divided by a positive, our overall answer will be negative. So sometimes you'll see the negative sign written in the numerator. Other times you'll see it written out in front. That doesn't matter. Same thing if I ended up getting a positive over a negative. A positive divided by negative is still negative. Okay? So that's how you calculate the slope of a graph.